Okay, this question has two components. So the first one is natural gas suggests more ground level methane exists than we are generally aware of. What do the climate modelers say about the impact of these data on their forecasts? And the next one is how do thresholds in the PA regs compare to OSHA exposure limits for methane and ethane?
Okay, so I'll try to, the first part of that question, I'm not a climate expert, so I really don't know what impact that may have on methane in the atmosphere. I do know that there have been studies done to show that methane generated in rice paddies and methane generated by farm animals is a gigantic contributor to methane emissions in the atmosphere. I don't mean to suggest that gas in the subsurface isn't adding to that, but methane is easily formed. It's just carbon and hydrogen. It's formed in the shallow subsurface and can happen very rapidly. And so it's a problem that is a natural condition as well. The second part of the question.
The regs, OSHA comparison to
OSHA. OSHA regs only deal with methane as an exposure issue if in certain environments. These are far more strict. Pennsylvania regulations are far more strict. They're looking at the occurrence of methane and the potential for it to create a problem to the public. So the numbers, for instance, 7 milligrams per liter is a very low number, and it often, the baseline background condition for methane in the groundwater often exceeds that. We did a study, part of the study that I talked about, we had some water wells that had methane as a natural condition in the groundwater at concentrations of upward 120 milligrams per liter as a natural condition. So the regs are more strict than what OSHA would do. And it's also important to note that that's a different environment. You're protecting workers that work with those hydrocarbons versus the public who's unaware of them. So they have to be stricter.
I'd just like to add that in terms of contribution, that slide I had to go over very quickly, that natural gas is about 40% of total emissions comes from natural gas, and it's the single largest anthropogenic methane contribution. So we definitely, because of the hydraulic fracturing process, which releases a lot of gas as gaseous flowback, when the geysers back up to the surface after the hydraulic fracturing process, that is released in the air and cannot be controlled. So it's very difficult to get a handle on trying to stop methane emissions from fracked gas. It's almost impossible. About 4% of all the gas that's carried through our pipeline systems leaks to the atmosphere as well. So we do know that shale gas is particularly potent.
Actually, we have a follow-up question, and maybe Tracy could expand on that. So the question is, in comparison with other energy or energy extraction methods, how does fracking compare extraction natural gas from shale formations? And in particular, what's the most understood risk of fracking, and what is the best? What is the least understood, and what is the best understood?
So there's a lot of studies going on right now. I mean, Robert Harworth of Cornell, Antonio and Graffia have done a landmark study. I saw it on Dan's slide. And that study really sort of changed the conversation about natural gas, because natural gas releases less carbon when it's burned. Doesn't mean that it's clean. Now, we discussed some of the environmental impacts, but just in terms of global warming potential, we know that natural gas has very high, is very powerful. And the EPA upwardly put upwards its analysis of the global warming potential of gas recently. And they say over 100 years, it's about 21 times more powerful than carbon in terms of global warming potential. Now, Robert Harworth says it's about 72 times over a 20-year period, and Schindel, which has done the most recent study, says it's 105 times, and that's also agreed to by Tony Ingrafia, more powerful than carbon in terms of global warming potential. But I think what we have to realize is that these are all fossil fuels, and all fossil fuels contribute to global warming. And we really need to turn this big ship around and start thinking about developing truly clean and renewable sources of energy, and not continuing down this path of fossil fuels, which inevitably contribute to our global warming problem.
I have a question now maybe for Dan. When would you expect a production well to be decommissioned? And could you comment about the life of the cement? The speaker mentioned 50 to 100
Yeah,
years.
these shale gas wells typically produce for quite a long time, for decades. They don't water out like a conventional well because there isn't mobile water in the shale. They just continue to produce gas, and they initially produce quite a bit up front, and then they decline rather slowly over at a lower level over long periods of time. As far as the integrity of the cement and the casing goes, yes, I've seen those studies. We, in fact, are looking at that in the context of using old oil and gas fields for carbon dioxide storage. You have to worry about integrity of the casing and the cement at that point. But in a depleted gas field, really by the time your casing deteriorates and your cement deteriorates, you're pretty much done producing. There just isn't much fluid left to move up. So I'm not sure it's quite as big of an issue as some people think. I also would like to comment on the greenhouse gas thing. We are doing life cycle analysis at DOE, looking at greenhouse gas emissions from natural gas systems, everything from the production to the transmission to the distribution system. There's a huge amount of uncertainty. If you look in the literature, you can find numbers of anywhere from 1% to 11% of throughput that is leaking into the atmosphere. So we are trying to identify those uncertainties and focus measurements on the areas where the data is the most uncertain to try to get a better handle on this. And, there's a lot of numbers being batted about, but the bottom line is we really don't know. We really need to get better data on that. And I've had discussions with Bob Howarth about this and with Tony Ingrafia, and they have said, well, really, what they're interested in too is just getting better data, that they have seen the same thing, that there's just a wide range of data. It's very spread out, and we need to define this better so that we need to find out what parts of the system are leaking so that those leaks can be fixed. The main problem seems to be in the distribution systems. It's old infrastructure, old gas pipes under streets and things like that are one of the main culprits for leaks.
Just one thing I'd like to add to that is that I don't think, though, that Tony Ingrafia and Bob Harworth would say they just want data. I mean, they are saying and they are advocating for us to turn away from these fossil fuels. And they are trying to get the truth out there about the global warming potential of methane. And so certainly, there is a lot of advocacy going on, and Bob Harworth has been slighted because of that. There have been more middle-of-the-road scientists who maybe have not been active and as much out there talking about their studies who are coming up with similar numbers, though. Oddly enough, because this competition has been set up between coal, oil, and gas, everybody ends up squabbling with each other about which is worse. That's not the point. The point is, what can we do to source energy for our nation and our world that does not cause global climate change? We need to develop those answers.
Okay, thank you. There's a question about the papers that were shown. I asked the speakers whatever documents you could share with me, and the documents will be at the site nrdp.njit.edu, so nrdp.edu. njit.edu, so you'll be able to download what was presented here. We have a question about freshwater, and it has two components. One is about the Catskill, and that's something we were discussing early on with the panelists. How would fracking affect the supply of New York City? Maybe Tracy can comment on that.
Yes. Well, first of all, there is a moratorium, a de facto moratorium in place in New York while they are updating their generic environmental impact statement, the study that is required under their state regulations that they do before they issue a new general permit. So they're in the process of doing that. It's been going on since Governor Patterson was governor, and they have been developing this data. They've had revisions of that, and we have been involved in studying that and commenting on that and hiring experts to basically go through these proposed regulations with a fine-tooth comb. Also, so they have looked at the reservoirs that feed New York City. Also, the Delaware River Basin Commission, which is the quasi-federal agency that oversees the Delaware River watershed, which is fed by New York, New Jersey, Pennsylvania, and Delaware. That commission also proposed natural gas regulations, and there is a moratorium in place while that process is going on. And they too looked at the potential impacts on the water supply for New York. As you probably know, whoever asked that question, the majority of New York City's water comes from the Delaware River watershed and reservoirs that were built many decades ago. And the concern was that if that water supply were to get polluted, where would those 7 to 9 million people on any given day drinking from the Delaware, where would they get their water because the Hudson is too polluted? Well, first of all, why don't we clean up the Hudson? That's sort of the obvious question. But second of all, certainly, any water that supplies any amount of water from the Delaware River, 17 million people get their water from the Delaware. Any water supply needs to be protected from pollution. And these reservoirs, which are located right in the Catskills where the Marcellus Shale is, would get directly hit. So New York City advocated to New York State that they make that area off limits. So in the draft regulations, New York State has put in place a temporary, it's only for 2 years and it can be re-examined and they can drill under the reservoirs, a 2-year prohibition of developing wells on the surface in the watershed that drains to those reservoirs. It doesn't mean that they're off the hook, and certainly many of us say, what do we, chop liver? Everybody downstream on the Delaware, the cities of Philadelphia and all them, all of us, the other millions of people, are we supposed to get polluted and not New York? But that's the short answer. We'll see how it actually plays out.
If I could just add a little bit onto that too. I don't think there's ever any reason to drill for shale gas in the watersheds that feed the New York City reservoirs. One of the things that the New York Department of the Environment is concerned about is this issue of cumulative impacts that I talked about briefly in my slide, where, sure, it could probably tolerate a few wells, a few shale gas wells without a problem. But at what point do you reach a limit? Where do you get to where, you can put 5 wells in a watershed? Well, what about 50? Well, what about 500? At some point, you get into this issue with the cumulative impacts where you irreversibly damage the water supply. And crossing that threshold, we usually don't know we've crossed those thresholds until after we've crossed them. So because of the risk, it's just not worth doing any drilling at all in New York City water supply watersheds.
Okay, question for Fred. What are your expectations in terms of your investigation on stray gas? I mean, do you think that there'll be a relation to drilling? Is it the operation? Is it the Marcellus Shale gas come to the surface?
Yeah, I think that clearly we have had incidents where the stray gas itself has been the result of recent Marcellus shale gas drilling. For sure we have. But the industry, honestly, what I've seen since the industry started in about late 2007, 2008, they have changed their behavior. They've changed their construction of wells. They've gotten a lot better. I mean, it's not something that they want either. And as I said, and Tracy talked about DIMIC. DIMIC was an actual incident. It was a stray gas migration incident. Now, some people will say that wasn't the case, but it was. I investigated that. That was related to gas well drilling that caused methane in the groundwater, caused a small explosion, caused some contamination of the water supplies. As a result of that, that was basically ground zero. Those regulations were put into place under John Hanger in 2011, and things have changed dramatically. Do we have some gas migration cases still, incidents? Absolutely. But things have improved a lot because of that. So I think the industry is getting better.
I would agree with that assessment.
One thing I'd like to point out is that there are problems that still go unaddressed. Bradford County, tremendous stray migration issues. Once the gas gets into the water, once pollution gets into groundwater, it's very difficult to remediate. And also, there are bubbles in tributaries to the Susquehanna River, in the upper part of the Susquehanna River. And that was 7 miles from Chesapeake Wells, and DEP went after Chesapeake for that. And they're doing a study to find out how to actually got 7 miles away. But when we're talking about this issue, we're not talking about just the next door neighbor. We're talking about whole aquifers which are connected, being impacted. In Dimmock, the number is 9 square miles that has been polluted, and it's only because it's not more densely populated that you don't have more individual wells that have been affected. But I think the issue of stray gas migration is Fred's area of expertise, and I think that one thing that we know for sure is that it's an ongoing problem. Yes, it may be better because they have tightened up their casing standards, but it hasn't gone away.
Yeah, it hasn't gone away. But the other thing to keep in mind, too, because of these regulations, when there's an incident now, they are required to investigate it fully and then to mitigate the problem so that the dosing of methane to the system stops. So they actually turn off that gas migration. It's if it is in fact related to that it is stopped because of that, and they're required to do remedial work on the wells to stop the gas migration.
Okay. In terms of freshwater, well, I'm rephrasing the question here. Where do you expect the biggest impact on freshwater resources, and which areas?
Well, 3% of the Earth's water is fresh, and about 1% of that is drinkable, and 99% of that 1% is groundwater. So what we are doing when we're impacting groundwater is we're really impacting the future of water for the planet. Now, we know that, and everyone saw the drought that's in the middle part of the country and Texas. We know that with global climate change, we expect these incidences of extreme weather to increase, and the water is a finite resource, basically. Now, we are being asked to sacrifice that, you could say, by the development of gas, and say, well, it's not so bad if 5 million gallons on average is injected for a Marcellus gas well. About 10% comes back up as flowback, and some of that comes back up over time as produced water. But basically, a large percentage of that water is completely depleted, consumed, gone from the subwatershed that it was taken from. And what is returned is in a polluted state, a state that it does not match its natural conditions. So we are really using up our fresh water, and we're playing a very dangerous game here in allowing these impacts to continue when we know that water really is bearing the brunt of it. Also, just as air, remember our air pollution is, I had it on one of the slides, we haven't talked about it much, it's none of our areas of expertise, I don't think, but tremendous air pollution problems are affecting the health right now in communities in Pennsylvania that are studies that are ongoing, and that pollution in the air affects, breathing it in, it affects vegetation, and it also deposits on water and impacts water.
Okay, so there's two issues related to water and the drilling. The first is it potentially impacts on water supply because they're getting this water from somewhere and using it. And then the second is potential impacts on water quality, which is what Tracy was alluding to. So you have to look at both the water availability for hydraulic fracturing and then how you're impacting the water quality. These are two areas that we are planning to address in this risk assessment, this multi-agency risk assessment study that I talked about. The EPA has been charged with looking at potential impacts on drinking water. So they're looking at both water supply and water quality, but in the context of drinking water. What has happened in the industry is there has been a shift in the water they've been using and how they've been handling their flow back and their wastewater, mainly because of economics. When the gas industry first came up into Pennsylvania, most of the people were from the Gulf Coast, and their experience with shales down there had been that if you used a low-quality water when you drilled and fracked, you were likely to cause the shales to swell up and close off your wellbore or collapse your wellbore or cause problems like that. So when the Marcellus play first got started, they were actually buying municipal drinking water supplies to use, drinking quality water, like drinking water, for fracking. And it's turned out that was really unnecessary. I mean, that was a major impact on drinking water supplies. But after they had worked with the Marcellus for a while and found out that it didn't have any of these swelling clays in it, they could use much lower quality water. Well, lower quality water is cheaper. So from an economic standpoint, they switched to lower quality water. So now they're using wastewater treatment plant effluent or raw water out of streams or water out of estuaries, things like that are actually non-drinking water supplies. In terms of disposal, again, when they first started on the play, they would buy the municipal drinking water, run a frack, get their flow back, and run that through a wastewater treatment plant, a municipal wastewater treatment plant. Well, most of the problems in the flowback are dissolved solids, and municipal wastewater treatment plants are designed to take out suspended solids, not dissolved. So it wasn't really treating the water. And there were problems with high salinity water with all this stuff, metals and things in it, getting into the streams at the discharge. Now, the common practice now is to recycle this water at the well site. So when they put multiple wells on a pad, so there's 6 or 8 wells, they will, when they get the flow back, they will filter it on site and recycle it into the next frack and reuse it. And then at the end, what you have left over when you're done is called residual waste, and that is typically trucked off to a disposal well, an injection well, where it's injected deep in the ground. These injection wells are used for chemical waste disposal. Considering some of the stuff they've put down them, frac fluid is probably one of the more innocuous things that has gone down these disposal wells. So that's standard practice. Not everybody is doing it, but the majority of industry is doing it that way now. And it's not really driven by anything environmental. It's all economic. So one of the points I like to make is that if we want these guys to behave in an environmentally responsible manner, we have to find an economic way for them to behave in an environmentally responsible manner, and then they will.
I just want to argue with one thing there. I think it's not correct that the majority of operators are recycling the waste. According to a recent report out of the Stony Brook University, New York University at Stony Brook, most wastewater is still being sent off-site and is not being recycled. A couple of the better equipped companies like Range Resources are doing recycling, but it's expensive to have these treatment systems. We're actually very concerned about it because there are no standards in place for how these treatment systems are supposed to operate. There's no water quality standards for them to meet with the finished product. And what you end up with, according to several studies, one of them recently out of New York as well, is a very highly concentrated toxic residue, which there are not adequate facilities to accept this waste today. As a matter of fact, the level of radioactivity in some of these residues is so high that there's only one facility that is within a traveling distance that could legally accept this material. That's why so much of it is flying under the radar, being mixed with other materials to dilute it and being sent to inadequate facilities that are not adequate to hold it. So I don't think it's true. I think that that this recycling is a basic trend that is most of them are doing. Also, 1.4 billion gallons of waste were produced in Pennsylvania in 2011. It has gone down some, but it is still a huge amount of waste, and a lot of it is being taken to injection wells. As a matter of fact, they so overloaded the injection wells around Youngstown, Ohio, where most of Pennsylvania was sending it, that it started causing earthquakes, and they had to put a moratorium in place because of earthquakes. And right now, USGS and others are studying it. The Ohio Environmental Agency are studying it to try to figure out how the earthquakes were caused, what it's done to the aquifer underneath. So I think, the problem of water is huge when it comes to shale gas. It's not being solved by the industry. I beg to differ with Dan. I think the way that we make industry do the right thing is we regulate them and we tell them they have to do it. Because they're going to try to cut corners because that's what they want to serve their bottom line. And certainly we have to recognize that as well.
I actually agree with you on that, Tracy. I think that this industry needs more regulations, and more important than that, it needs more enforcement of the existing regulations. There are just not the regulatory work for shale gas drilling, for all oil and gas drilling, is typically done at the state level. State agencies are the ones that issue the permits. State agencies are the ones that enforce the permit requirements. So it's not done at the federal level. The only federal agency that has any regulatory authority at all is the EPA, and it's pretty limited on what they can do. It's left up to the states. So the way that this is regulated really varies from state to state. I live in West Virginia, and the regulations in West Virginia are really not very, well, the regulations themselves are not very strict, and the enforcement is not very strict. And in West Virginia, for example, there is no regulation about how much water you can take out of a stream. So if you're a driller and you need frack water or water for your well, you can find a stream that has public access. You can pull up a tanker truck, throw in a hose, and take out as much water as you want. Well, in the old days when they were drilling small wells, they needed 10,000 gallons of water for a cleanup or something. That was no big deal. But if you're taking out 4 million gallons of water for a frack job, and your competitor is upstream on the next bridge doing the same thing, and nobody's regulating this, it can cause some real problems to things like water flow, bypass requirements, stuff like that. So there are some changes that need to be made, and some have been made, but more need to be made to adapt oil and gas drilling regulations in many of these states for this new kind of production. They're just not geared up for it.
Okay, one of the questions was, what's the lifespan of shale gas? I mean, for how much resources exist there for our usage?
Well, there's a lot of debate and discussion about that, and a lot of different opinions on that. The sort of the baseline agency for determining that is the U.S. Geological Survey, and they have recently come out with some assessments of the amount of gas, what the gas in place is, and what the recovered gas might be. The resources are actually fairly large because you're moving into a lower quality resource, so there's more of it, and the numbers that have been tossed around are about 500 trillion cubic feet of gas available in the Marcellus, with about 10% of that recoverable, which is 50 trillion cubic feet. Some people think there's quite a bit more. It depends on if there's advances in extraction technology that'll let you recover more than 10% of the gas. But all of the conventional oil and gas reservoirs in the world have a source rock somewhere underneath them that generated the oil and gas that filled up these conventional reservoirs. So the source rocks are what's being produced for this shale gas. And I think once people start looking at that, they're going to find a lot more than anybody ever expected.
Okay.
I just wanted to add one thing, that just as a statistic, we use about 23.5 trillion cubic feet of natural gas currently today in the United States.
Per year. Yeah,
yes,
per year.
Annually. And so that figure that you're talking about, 50 trillion cubic feet, well, we're talking about just a few years worth of gas if you were to take it out all at once, theoretically, from the Marcellus Shale. So when you hear people talking about the Marcellus Shale giving us gas like Saudi Arabia gives oil and it's going to last for 100 years. That's a lot of hype, and there's a lot of companies that are pumping that hype up. So I think we need to have an unsentimental eye looking at this issue and realize that this is really, nothing is really proven until you go in there and actually get the data from the wells themselves.
Okay, one of the questions is, why is this different, this gas industry, why is it different from oil industry? I mean, in other words, I think one of the speakers mentioned about the gas industry. Are there some steps that could be done to make the process safer in terms of the drilling? I mean,
Well, sure. I mean, and really there is not a lot of difference between the gas industry and the oil industry, especially now, because the oil industry has discovered shale gas, and you've got some major oil companies that are now drilling in the Appalachian Basin, like Shell, Exxon Mobil, Chevron. These guys showed up after the large independents like Range and Chesapeake got the place started. But once the big boys weigh in, then you know that it's probably a pretty serious resource. But there are a lot of people looking at ways to reduce risks on the drilling and production, and there's industry is doing that, and other groups are studying that as well. Nobody wants these problems. Nobody wants to have these problems, and they would rather have things be problem-free because it costs money if you have problems. So, I think there is a desire in industry to do it right and not have to deal with the violations and the incidents.
I think one thing that Dan says is very true. Cost is, a very important factor when you look at how safe can it be. I mean, we feel that there are unmet technical challenges having to do with the competency of casings and cement and other issues related to this. How do you treat the wastewater and take all the frac fluid pollutants out of it and the deep geology pollutants as well? But really when it comes down to it is we heard about that it's become economically viable because of the drilling techniques to take this gas out of the ground. But we have not heard, and we believe that the industry really has not taken a look at, and certainly regulators have not taken a look at, what is the economic viability of cleaning up the pollution caused by the shale gas revolution. So this shale gas rush has delivered a tremendous myriad of environmental problems that we are handling, or not handling, but that we're facing. And as a result of that, if we were to tell them that they had to figure out how to clean it up, how to drill safely, how to handle stray migration, how to not destroy everything in your path on the landscape when you're drilling. If we were to really task the industry with that, then they would be no longer able to pass on or externalize those costs that they're externalizing now. The first thing we'd have to do is get rid of all of these exemptions that I mentioned in my talk. The second thing we'd have to do is tackle all the technical unmet issues. And that requires time. A moratorium should be done in the meantime, but it also requires money. And is it going to be economically viable for the industry to continue to develop shale gas if they have to pay for all those costs? I think that's the big question.
We're going to have to stop. This is a very interesting topic. I would like to thank you for joining us and our distinguished speakers. Let's give them a hand.